Good morning. As we remarked in our previous lecture, the number of R combinations from a set with n elements is often denoted by n choose R. This number is also called a binomial coefficient because these numbers occur as coefficients in the expansion of powers of binomial expressions such as the quantity a plus b to the power n. We will discuss the binomial theorem, which gives a power of a binomial expansion as a sum of terms involving binomial coefficients. The binomial theorem, example 1. Produce the expansion of the quantity x plus y to the power 3 by employing combinatorial reasoning instead of finding the product of the three terms. Solution. When x plus y to the third power is equal to x plus y times x plus y times x plus y is expanded, all products of a term in the first sum, a term in the second sum, a term in the third sum are added. Terms of the form x cubed, x squared y, xy squared, and y cubed arise. To obtain a term of the form x cubed, x must be chosen in each of the sums, and this can be done in only one way. Thus, the x cubed term has a coefficient of 1. To obtain the term of the form x squared y, x must be chosen in two of the three sums, and consequently a y in the other sum. Hence, the number of such terms is the number of two combinations of three objects, namely 3 choose 2. Similarly, the number of terms of the form xy squared is the number of ways to pick one of the three sums to obtain x and consequently take a y from each of the other two sums. This can be done in 3 choose 1 ways. Finally, to obtain y cubed term is to choose the y for each of the three sums of the product, and this can be done in exactly one way. Consequently, it follows that xy to the power 3 is equal to xy times xy times xy, which is equal to xx plus xy plus yx plus yy times the quantity xy, which is equal to triple x plus double xy plus xyx plus xyy plus yxx plus yxy plus yyx plus triple y, which is finally equal to x cubed plus 3x squared y plus 3xy squared plus y cubed. Theorem 1, the binomial theorem. Let x and y be variables, and let n be a non-negative integer. Then x plus y to the n power is the sum from j equals 0 to n of n choose j, x to the n minus j power, y to the j power, which is equal to n choose 0, x to the n choose 1, x to the n minus 1, y, n choose 2, x to the n minus 2, y squared, plus, 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 all the way down to n choose n minus 1 times x to the n x times y to the n minus 1 plus n choose n y to the n. Example 2. What is the expansion of x plus y to the fourth power? X plus y to the fourth power is equal to the sum from j equals 0 to 4 of 4 choose j, x to the 4 minus j, y to the j, which is 4 choose 0, x to the fourth, 4 choose 1, x cubed, y, 4 choose 2, x squared, y squared, 4 choose 3, x, y cubed, and 4 choose 4, y to the fourth, which is x to the fourth, 4x cubed y, 6x squared, y squared, 4xy cubed, and y to the fourth power. Example 3. What is the coefficient of x to the 12th power, y to the 13th in the expansion of x plus y to the 25th power? Solution. From the binomial theorem, it follows that this coefficient is 25 choose 13, or 25 factorial divided by 13 factorial divided by 12 factorial, which is 5,200,300. What is the coefficient of x to the 12th, y to the 13th in the expansion of 2x minus 3y to the 25th power? First, note that the expression 2x plus a minus 3y to the 25th, by the binomial theorem, we have 2x plus a minus 3y to the 25th power is equal to the sum from j equals 0 to 25, 25 choose j, 2x to the 25 minus j, minus 3y to the j power. Consequently, the coefficient of x to the 12th, y to the 13th in the expansion is obtained when j equal 13, namely 25 choose 13, 2 to the 12th minus 3 to the 13th is equal to minus 25 factorial over 13 factorial over 12 factorial times 2 to the 12th times 3 to the 13th. Corollary 1. Let n be a non-negative integer, then the sum from k equals 0 to n of n choose k is equal to the n. Corollary 2. Let n be a non-negative integer, then the sum from k equals 0 to n of minus 1 to the k, n choose k is equal to 0. Remark, n choose 0 plus n choose 1 plus n choose 4 plus dot 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 is equal to n choose 1 plus n choose 3 plus n choose 5 dot dot dot. Let n be a non-negative number, then the sum from k equals 0 to n of 2 to the k, n choose k is equal to 3 to the n. Finally, Pascal's identity in triangle. Pascal's identity, let n be and k be positive integers with n greater than or equal to k. Then n plus 1 choose k is equal to the sum of n choose k minus 1 plus n choose k.